My name is Rani Lill Anjum. I work at the Norwegian University of Life Sciences outside Oslo. I'm a philosopher by training, and I've been doing philosophy of causation for the last 10 years. And the last 5 years, I worked on causation in medicine and the health sciences through the research project called CauseHealth. So CauseHealth, it's short for Causation Complexity and Evidence in Health Sciences. And I didn't do any philosophy of medicine before. So it's more about the people I met, and among them Roger Carey. And through him, I also met Matthew Lowe. And so I've been getting more and more into this clinical side of philosophy of medicine through this project, which I didn't know before, because I thought people also in public health would think it was interesting. But it seems like all our slogans with n equals one and statistics don't get me and one size does not fit all seem to be a better fit for clinicians. So yeah, this project has taken me places where I couldn't have predicted when I applied for it. So it's been very interesting. Today I'm going to talk about two philosophical theories of causation. And we will also see that there are two approaches to causality that are influenced by a deeper underlying ontological understanding of how the world is. So the idea here is that what general philosophical perspective one comes from, one will have different understandings of causality, which again is going to influence how we think of causal evidence and the best methods to find causal evidence. And it will also affect what we think is the best practice, for instance, evidence-based practice or more person-centered practice, because many people think that you can choose to be a bit of both and it doesn't matter because they are very complementary. In my talk, I'm actually going to say that they are quite different and that they are motivated by two completely different worldviews and two completely different concepts of causality. So that's what I will try to show. So if we start by looking at the theories of causality, I will talk about a Humean notion of causality that is developed by David Hume. And then I will switch into talking about a dispositionalist approach, which is a very different theory from Hume. Of course, there are many other theories of causation, but these are the two that I think are the most obvious contrasts. And I think also that they each motivate different thinkings in healthcare and science in general. So the first one, which is the Humean theory, is starting from an empiricist perspective, because Hume, he was a strict empiricist, which means that he only wanted to believe as true what he could have experience of. So if we cannot experience or observe something, then we don't know it. So he was very skeptical of trying to speculate about how the world is outside of those observations. So we should stick to what we can know. So for him, if we want to say that something is cause and something is effect, we need to see what can we actually observe about causation. And he said that, well, when we look at a typical example of causation, we could look at, for instance, the billiard ball table, which he thought was exemplary. All we see is that when you shoot a billiard ball, it will roll and it might hit another billiard ball, and then afterwards the other billiard ball is going to keep to start moving. And then he says, if we say this is a typical case of causation, then what can we analyze it into? well, first we see two events that happen together, and one event happens before the other, and there is some contact between them. So that he said, first you need regularity, but you cannot just see what happens on the billiard ball table once. It couldn't be a unique case. If it only happened once, we would never say, oh, this must be cause and effect. We have to see the same things many times. And the idea about temporal priority is that, well, if both happened at the same time, we wouldn't know what is cause and what is effect. So we always need to look at, when we see a regularity or a correlation, we need to think what happened first. And what happened first is the cause, and what happened after is the effect. And also, if there's no contact between them, that you shoot a billiard ball in Norway and then in UK another starts rolling, then we would think, well, that's not causation because they never met. You know, so that's why he says there has to be a meeting in time and place. But what he says we cannot see is that there is a kind of necessary connection between what happens first and what happens after. So for him, any kind of causal claim could not be a claim about an intrinsic relationship that gives you a reason to say, well, next time I shoot a billiard ball in the same way, the same kind of thing is going to happen. So if we could see that kind of connection, then we would also be able to predict in the next case what would happen. So his theory has been called a regularity theory of causation, which many people have tried to object to because they say, well, there is some necessity between those two events, for instance, in the laws of nature. You know, so there are forces, but Hume said we cannot really see those forces, so we don't know about them. So for him, this kind of cause and effect view is a bit like when you have a screensaver and you have this little ball that doop, 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 it bounces off the edges of your screen, you know, but you know it doesn't actually bounce off the edges because it doesn't hit anything hard and is nothing hard. So it just appears to be interacting with the surface, but actually all we see is a kind of regular behavior that makes us think there is some cause and effect. So for Hume, it's a bit like that. We're standing on the outside, looking at the world and seeing these kind of regularities and trying to figure out, are they causal or are they not? So the way that he thinks about causation here means that epistemology, what we can know, what we can confirm and have evidence for, it trumps whether or not it's actually causation there. It's a bit like with the coronavirus, you know, if you don't test it, you don't confirm it. So anyone who gets a confirmation that they have the coronavirus, it's only because there is an epistemic evidence for it, namely that you tested. And if you knew nothing about how the virus operates, you might think that, well, actually, only people who get tested get the virus confirmed. So maybe it's something in the test that gives you the infection, you know. So you could start thinking like that. But it's very important that there's not more to causation than what is in the test. And the test is there regularity, is there temporal priority of the cause to the effect, and is there a connection between them? And this theory, he also expanded it to be a kind of counterfactual theory, because he said, well, whenever you have the cause, you have the effect. In other words, if you didn't have the cause, you wouldn't have the effect. It's not really in other words, but if you didn't have the cause, you wouldn't have the effect. That is to say that the cause is actually a kind of necessary condition for the effect. And this has also been a very influential understanding of causation, that if you take away the cause, then the effect shouldn't happen. So you cannot say then that you have causation going on if you don't have an observable effect. So that's a major implication of that theory. He also said that that when you think of causation, you have to think of it as a law-like behavior, even though you don't think there is a law of nature underlying what's going on. There is a law-like statement that, well, these things happen generally, which is why I can believe it's going to happen here. Although that would be an inference that goes beyond what you can observe. For instance, if you have a cup and you think, is this going to break if I drop it? You could say, well, the reason why I would think so is that I have seen things like this break under similar conditions before. So in that sense, when I say that cups can break when you hit them, it's because there is a kind of correlation lying behind. So that's the kind of law that we have. So that also means that if something happened only once, it couldn't be causation. So it has an implication that the first time something happens, we could never say, oh, this must be causation, you know, because for him, he said that if the creation of the universe happened only once, it cannot count as a cause, you know. So this is because of his criteria of repetition. I think it's another interesting aspect with Hume, which is that since he was a strict empiricist, he would only observe what happens or doesn't happen. He doesn't say anything about what could possibly happen or necessarily happen or any potentialities, you know. Everything is just facts or occurrences and non-occurrences. So that's also why this necessity, it's not observable, because it's not there as a fact in what actually happens. I will show you this model of causation that comes from the Humean understanding, and it's a kind of a neuron model of causation, we might call it. You can see that it looks like the billiard balls. You have a cause A, so that's the first event, and you have a second event B, and then you wonder, is there an arrow between them or not? Is it linked? You know, so what we can observe is A and B. And this is typical for when we look for correlation. So you find a correlation A and B, and then the question is there causation or not? And we see also that this is a model that focuses primarily on one cause, one effect. So if you have the cause, you will have the effect, but is it because of causation or not? So on this view, there is also an asymmetric relationship between the cause and the effect. It's not like A causes B and B causes A, because that would mean that the temporal priority would be lost. So it's very important that these are events that happen after each other. I would also say that this empiricist starting point, where you start from what can be observed, and then you have this view of causation that you look for repetition, it also gives a particular view on probabilities. So if you're going to say, okay, maybe you cannot predict that for sure, whenever you have A, you will have B, maybe you can say, well, when I have A, it makes B more probable. So maybe it's more probable or more likely that you get the effect. So for instance, in many medical interventions, you wouldn't get 100% success. But you could still say that, well, when I use this treatment, 30% of the people who get it, they improve. So does that mean that this treatment raises the probability of recovery with 30%? You know, is it like a 30% probability? I mean, this is a frequentist understanding of probability. And the idea there is that you try something like an intervention, or you produce the cause many, many times, and then you see how often you get the effect. So you can think, well, if I drop this pen, it's going to fall, and you do it, and it falls, and you do it many, many times. And then you can also count what is the probability that it's going to happen. And so if you think of a coin toss, which is a typical probabilistic case, you can say from a frequentist perspective, to know that it has 50-50% chance of landing heads or tails would be a result of counting. If you didn't count, then you don't know. So that's very important. And from the count, if you have a big enough sample and a representative sample, then you have your probability. And that's why under the frequentist approach, you can have very well-defined probabilities like 18.5% probability, because it's all about the numbers. Okay, so now I'm going to move over to a dispositionalist understanding of causation. So on this view, which is very different from the Humean, we actually, instead of starting from epistemology, what we can know from observations, we start on speculations about how the world is. And that's ontological speculation, as Hume said. And he doesn't like it because you have no evidence for it, he would think. So in this dispositionalist theory, we say that, well, if you want to understand why causation happens, you have to start looking at the properties of things. And in particular, you need to look at the properties that are of a special kind, namely the dispositional properties, because they are the ones that give you causal powers. And there are many people who are dispositionalists, and many of them would say the same that Hume says, except they would say that it's a disposition underlying the causal relationship. So if you want to have a causal law, you can find it in a disposition. For instance, if something is fragile, which is a dispositional property, then if you strike it hard, then it will break. So then you can say striking something fragile is the first event, and the second event is that it breaks. So then you have the disposition and a certain stimulus, and then you have the effect. And you can see that under repetitions, this will happen many, many times. And there you have your Humean view with the dispositionalist foundation. So this theory that Stephen Mumford and I worked from is different, because we want to say that on every step of the theory, it is different from what Hume assumed. So a dispositional property is a property that can exist without manifesting. So for instance, something can be fragile, but it doesn't have to break. Someone can be fertile, but they don't have to ever reproduce, you know. So something can be toxic, carcinogenic, you know, but it doesn't have to do the causal work. It lies there potentially. That's why Hume didn't like it, because it's all about potentials. This kind of dispositional properties, he would say, well, the only reason why you think something is fragile is because you have seen them breaking in the past, similar things breaking. But we would say that, well, if they break, it's because they were fragile. You know, so the fragility is something that is intrinsic in the world, you know. So these type of dispositions, we say they are clearly qualitative. They're qualitative and they're irreducibly so. But you can still say that something is more or less fragile. So I will share the screen again to show. Let's see here. So here you can see it's a different model where we model causation as a vector. And the vertical line with the arrows, that's the starting point, and the horizontal arrows is showing the degree of a disposition. So there is a line here that is a dotted line, and it's also vertical, and that's the threshold effect. So you could say here that if you have, for instance, something that is very fragile, like a wine glass, it is very close to the threshold effect for breaking. But you could also have something that is fragile, but very little fragile. So it's it's a much weaker form of fragility, like for instance, a car window. It can break, but it takes much more to bring it to the threshold. So you see here, it's far away. So to get it to the threshold, you will have to add a lot to this situation. So these are about the qualities. It's not about how often a wine glass will break, so that, for instance, the threshold effect is showing 100% success whenever you try it. That would be a very human approach. Then you would say, okay, if it breaks all the time under the same conditions, it is like exactly on the line. And then the other line would be like, well, it only breaks in 10%. I mean, in this approach, it doesn't matter whether it's manifested or not. The disposition itself is lying there, and it's not going to look much different with respect to the effect unless it gets some kind of trigger. So that's a difference in these two. So you see here that on Hume's theory, it was like if you don't have an observable effect, you don't have causation. Here you have a lot of causal powers, and the fragility is there, even if it doesn't break. But it doesn't mean that there's nothing underlying and happening, and that these are two different situations. So it also means that depending on the strength of the disposition, something might be more likely or not to occur, or it might also mean that it can happen to a different degree or at a different stage. So a wine glass, I mean, all you have to do is put it in warm water and it will break. But a car screen, a car window, you might have to hit it with a hammer. I don't know. I haven't never tried. So that's why we also say that any kind of causal production happens when different types of disposition interact. So you wouldn't have something breaking without interacting with something, for instance. So to have one disposition doesn't mean that it would just manifest itself spontaneously. There could be that kind of dispositions, but that wouldn't be the typical type of causation. The typical type of causation, for instance, for fertility is that you need what we call a mutual manifestation partner. So yeah, you can have a fertile woman with the egg and the uterus and all of that, but you would need the sperm. But you also need to have a lot of other properties working out in order for the pregnancy to happen and to continue. So there's, on this view, it's not like you have the cause as a single event and the effect as a single event, but coming together of different dispositional properties start a causal process that is one continuous event of change. So it's a change that you can actually observe. So it's not like you have something happening over here and then you have something happening over there and you're blind for what happened in between. Here you can start off something by meeting, and then you can look at the process along the way. And in this sense, when you have, for instance, a fragile glass, you also have to think of, if you hit it with a hammer, that the hammer has a particular property. It cannot be a hammer made of foam. It has to be one that is hard, and you need to strike it, you know. So there are all these dispositions or causal powers coming together. And that means that it's not just the striking that is the cause of something breaking, because that means that you can go about and strike all bunch of stuff, you know, all different things, and they should all break, but that's not what's happening, you know. You can hit something and it doesn't break at all because it's made of steel, for instance, and you can hit something that gets a bump. But so this same type of intervention or trigger wouldn't give the same kind of effect in different conditions. And that's why we say also that causation is extremely sensitive to context. You cannot have one disposition and change everything else and think that you get the same. You have to have focus on everything that is involved. So it means that if you change a tiny thing in the causal setup, you might get a huge difference in the outcome. For instance, if you think of striking a match causes it to light. And of course, you can try that out in rainy, windy weather if you're out with a tent, you know. Or you can try it at for instance, a petrol station, you know. So maybe two completely different things will happen. In the first case, you're lucky if you get a spark, and in the second, you might blow up the whole petrol station. So those are the same cause in different settings with extremely different effects. We also talk about different types of causal interference, because if you want to counteract the effect when you have the disposition, you can do it in two different ways. For Hume, it looks a bit like once you have the cause, you will get the effect, because otherwise you don't have the regularity. And then if you don't get the effect, you might say that, well, you didn't really have the cause, because the cause is everything that you need to get the effect. And a lot of dispositionalists have done the same. They have said you need to have the disposition and the trigger and all the other right conditions, and then necessarily you get the effect. But here it's, instead of looking at, okay, you have this causal factor here, this disposition, and it can manifest in this way, but how can you avoid it, for instance? So I will share now the screen again. Let's see here. So for instance, you can have subtractive interference. So the dotted line here with an R is the resultant vector, and the dotted arrow is the cause or the disposition that you want to remove. So here, if you have two dispositions, so for instance, you might have high blood pressure, and you want to avoid that. But the reason why you have high blood pressure is that you have a very salty diet and a lot of stress, and you have the genetic disposition. Then you can remove something. Maybe you can remove the stress. Maybe you can remove the unhealthy diet, and that will change the outcome. But of course, most of the time, people want to keep their behavior, but they still want to lower their blood pressure. And then you can use additive interference. So that means that you add something on the opposite side that will counteract the effect. So that would be what any kind of medication almost is relying on. You know, so you can continue with your unhealthy lifestyle, but you add medications, and then, you know, you can be relatively healthy. So here I also wanted to show this idea that causation is complex, that you have many dispositions. Some are disposing towards the effect, and some are disposing away from the effect. So here you can also think of the striking the match you know, that you have the rain will counteract it, you have the wind will counteract it, but the flammable tip and the wood, you know, and the striking with the spark, those are going to dispose towards it lighting. So that means that for any kind of causal situation, there will be all these counteracting dispositions. I wouldn't want to assume here, of course, that that all these dispositions act in linear ways, so that when you add, you get more. I mean, the model it shows it because it's the most simple model. The idea here is that the most common way for dispositions or causes to interact is non-linearly. So we cannot just assume additivity. Also on this view, it is important that it's only as long as the dispositions are there that you can see an effect. So for instance, if we look at, if we think of the Humean model, where first you have an event and then nothing, and then you have another event, and then you wonder if there is causation between it, then of course it's very important that you have the temporal priority. But we're thinking of the temporality more as a process that takes time. So for instance, I have this cup and I want to lift it. And of course you can think, okay, now I want to lift it, and the next moment it's lifted. Okay, so that would be one way. But the idea that we go for with the dispositionalist approach is that it's only as long as I use my causal powers to lift it that the cup will be lifted. And once I stop, it will fall again. You know, so that's a different way to understand causation, which means that there is a temporality involved, but the temporality is because there is a continuous process. So at this continuous process, you might think that you might see that there are new powers coming in and other powers disappearing. You know, so to keep a process going, you might have to add something. So it means that you cannot just start, for instance, a treatment and think that it's going to continue until recovery without anything like following up. It's only as long as you follow up and follow through that you will get an effect. So that's the same even if you take a pill. You take the pill, but it's because that pill starts interacting with the body. And only when that pill has stopped interacting with the body completely will the effect stop. You know, so as long as it's there, it's doing causal work. It doesn't mean that your headache is going away, but it's doing causal work. So you might, for instance, get a side effect even if you don't get the effect. I mean, because there are many things that can be done. So on this view, probability will also be something that is an intrinsic, complex, and context-sensitive matter, where you look at the qualities of things to know how it will, what kind of probability an outcome has. So for instance, if you're thinking of the coin and that it has 50-50 chance of landing heads or tails, then instead of flipping it repeatedly and count, you will study the coin. You will see that it has two sides, the weight is pretty evenly distributed, and you will look to the properties to see, I think 50-50, you know. And the coin is not the biggest problem because it's fairly simple, but if you're going to say, well, what is the probability of me breaking a leg if I fall out the window from the 3rd floor? I mean, from a frequentist perspective, you can of course look at the statistics and see how many people broke a leg when they fell down from this kind of height. And then you're going to give my probability. And then if you want to be even more specific, you can see, well, people my age and gender. But what you would do on a dispositionalist perspective is to see, okay, what is down there? Is there asphalt? Is there water? Is there a mattress? You know, how high is this 3 floors? How flexible am I in my body? How did I fall? You know, you would consider all these properties and how they would interact, and you would never ever be able to come up with a very clear number for what kind of probability you would have. When I ask my students, they would say, maybe 5% chance, maybe 99% chance, maybe 50-50, you know, it's a lot of guesswork and it doesn't sound very scientific, but also it's what would give you the rationality to even talk of, you know, that you raise a probability. But it's not an empiricist starting point. Yeah, so then I have talked about the 2 theories, and for the rest of the talk, I'm going to say how this affects scientific methodology and how we go about studying causation. So now I will look at how these different philosophical theories of causality motivate different types of scientific approaches and scientific methodology. In evidence-based method, there is a clear hierarchy where statistical methods are given priority to more kind of qualitative and mechanistic evidence. Usually in science, there's not this clear hierarchy, and also evidence-based medicine, they now say that it's a bit more egalitarian, but it's still clear that randomized controlled trials and meta-studies are seen as extremely important to discover causation. And I want to show how there is a very clear human motivation behind this. So first of all, evidence-based medicine and methodology gives priority to data over causal theory. And this is really fitting with Hume's empiricism, which says that causation is nothing but a certain type of correlation, and that it's derived from what we can observe. So you can observe the repetition, temporal priority, and the contact. So it makes sense that if you want to know, is there an arrow between those two balls, then you start from correlation data. So even though it's much more advanced than correlations, it's advanced analysis of correlation data and comparison of correlation data. So in evidence-based medicine, we start from the quantitative and statistical methods, and we say this is where you establish causation. And of course, there you also assume that more data is always better. And if you could have a perfect data set, of course, that would be amazing. And that's very similar to what Hume thought, because he said, we cannot know anything that has not been observed yet, which is why we can never say anything about future or unobserved cases. So even if you have perfect data from what you have until now, so all the dropped pens, you have seen whether they fall or not, you cannot say something about the unobserved cases. But if you said from now on, we're going to stop dropping pens, so we have a closed set and we have all the data, then you would know 100%. And this is also why we need this kind of representative set or big enough set when we look at causation. So it means that when you have, for instance, one clinical study, you don't have really large numbers, or you have as large numbers as you can manage. But if you have many clinical studies and meta study of clinical studies, then you have bigger numbers. So you have more numbers and therefore more representative, and therefore your predictions are going to be more robust. So this is the more data, and large-scale correlation data and systematic reviews, they come from this Humean quantitative approach. It also means that we want to use these statistical tools to decide in each individual case what we should do. And so it means that you start from the general observations to the particular. And that was also what Hume did. He said, if causation happens here, the only rationale we have to say that this is the case is because it has happened elsewhere. So if you sit with the patient and you think, did this patient actually get this effect from this treatment? Well, yeah, I have the data from all the other patients showing that there's a bunch of people who got this effect from that treatment. So therefore, I have a reason to say causation happened here or causation will happen here. So that's this kind of going from the general knowledge of what you have observed to the particular case here. But of course, once you say that what you find on the general statistical level can be applied to an individual case, you will have to be a frequentist about probability. You will have to say that actually, this is exactly how you find the probability in each individual case. If the most effective treatment treats 30%, then you have a 30% chance of being cured with this treatment. And this is exactly how you find the probabilities. Of course, some people would say it's a problem with the ecological fallacy that you go from group level to individual, and they might think that each individual has different probabilities. But then you can maybe look at subgroup and say, well, yeah, people like you have a different probability because in your subgroup, it's not 30%, it's only 10%, or it's only 1%. But then you have tried to narrow down and found the most relevant group. And that's the same you would do under frequentism. You would try to find the subgroup that is the most relevant. So many medical researchers have also talked about this kind of monocausal model, because if you want to really look at a complex illness and you want to say, well, can you really have something that is caused both by a psychological and a biological factor and maybe your social situation? Well, if you think so, you have to do individual studies for each separate element. You cannot say, okay, let us look at the whole situation, including the genetics and the social and the psychological, and then we will see whether those kind of things together can cause this outcome. No. For Hume, you would have to isolate and do one by one. So you have to do one study for maybe this gene, maybe one study for a social type of stigma, or one for instance, how prone someone would be to depression. So this is something that the biopsychosocial model was supposed to deal with. It was supposed to deal with this kind of complexity, but you will have to fragment the problem into something that can be treated within the monocausal model of the one cause, one effect. And it's also because this, if it hadn't been for the cause, you shouldn't have the effect. And once you look at the big complex situation, you don't know, was it this or was it that? So we see the same when we want to do clinical studies of a certain drug. If you give someone 10 drugs, or someone is already on 9 drugs and you give them a 10th, you're not going to know whether it was this one that made the difference or some of the other things or something else completely. So you have to test something on people who are not on all these medications if you want to really establish the effect. So if we actually study each of these components, so you study, for instance, the causal powers of this drug and this drug and this drug in separate, you have to assume the principle of additivity afterwards and say, so this is effective, and this is safe. And when you add them together, you're going to get the same. And that is a particular view on complexity, where the world composes. And that means that the world would have to consist of parts that don't really interact. So it makes it hard to treat a person as a unity. But it's something that follows from this methodology. So if we look at this Humean approach in practice, we see that its very typical approach is to look for same cause, same effect. So the same cause should give the same effect under the same or similar or ideal conditions. And if you don't get the effect, there must have been something that was different in the cause, because if you had it, you should get it. So if you think of causation in this way, it's something that is quite robust. And I think that makes sense when we look at the clinical trials, because what you do is that you take the same type of intervention and you give it to a variety of different contexts, and then you see whether the intervention managed to push its effect through across all those contexts. So in a way, if it's truly causal, it should be able to survive contextual change. I mean, otherwise you would have to do personalized interventions for everyone. So causation here is a bit context insensitive because it's already baked into the assumption that if you had the identical context again, then you should get the effect. So I think this is very typical in all medical sciences, because we assume that the same type of medical history should give you the same symptoms. And if you have the same symptoms, then you should have the same diagnosis. And if you have the same diagnosis, then you should have the same intervention. And hopefully when you have the same intervention, you should have the same effect, you know. So this kind of same is very deep rooted in that Humean approach. So it means that we know that there are individual variations, but this is not the focus. When you study causation on this Humean model, you're going to count how often you get the desired effect. And of course, there might be that you get undesired effects like a side effect that is harmful, and you do a separate study for that. But even when you do the separate study, you're looking at only this side effect, you know, and ignoring all other effects. So it is always focused on same cause, same effect. And of course, you can have these subgrouping, but within the subgroups, there should always be same cause, same effect. And of course, this is something that is working quite well in medicine. There are many of these type of same cause, same effect that we find, but one thing we noticed in the and that motivated the CauseHealth project was that we learned about these medically unexplained symptoms, where low back pain, non-specific low back pain, for instance, is one of them, and many other chronic pains, fibromyalgia, and also irritable bowel, and you know, all these general anxiety disorders, tension type headaches. There are all these kinds of conditions or symptoms or complaints that don't have this clear same cause, same effect thing. And it's one thing we learned was that this is not a marginal part of medicine either. It's like up to 50% of all health complaints are medically unexplained. You know, so it means that this is a huge problem. And what they saw was that it's very large individual variations, very complex causes. It's not like one biomedical cause or one physiological cause that you can point to. It wasn't clear psychosoma division, and it was medical uniqueness. And all of this would be extreme problems for the Humean perspective, because you don't get, I mean, you end up with this crazy n=1. So from the dispositionalist perspective, we said, well, all of these things is what we say is typical for causation. It should be singular, because we could never assume that you can repeat a context twice with exactly the same dispositional properties involved. I mean, even from me, from one day to another wouldn't be the same dispositional properties involved with all of my context and all the influences, or even my own body. And especially not from one patient to another or one individual to another. So why would we have a theory of causation that would have to start from a very theoretical assumption that you could have the same context twice? So on this dispositionalist approach, it doesn't matter whether you've seen repetitions many times before. What matters is what is here and now intrinsically in this situation. So for instance, if you want to say that smoking causes cancer, on the dispositionalist perspective, it doesn't help that you can just count that people who smoke get more cancer, because that would be a bit like with the coronavirus, you know, so the people are tested are more likely to get confirmed that they have coronavirus. So if you didn't have a kind of idea that there is an intrinsic property of the cigarettes that would bring about the cancer, then you couldn't, from a dispositionalist perspective, claim that there is causation there, which means that you need to have a theory of causal mechanism, which is very low down in the evidence-based hierarchy. So you need to say, what are the dispositional properties underlying here? Which are the manifestation partners, and what are the appropriate manifestation partners? What would counteract this? Could there be interference in an additive way, in a subtractive way? You know, what contextual differences would mean that you get a different effect? you know, because not everyone who smokes get cancer. So there must be something that makes it, that makes you more vulnerable or more robust. So all these kind of mechanistic speculations would have to be an important part of the causal evidencing. And it's also really important that we have focus on this complexity, because if you have focus only on, for instance, the medical intervention or the pill, it seems like you can put the pill on the table and hope that it will heal or cure someone, but it's not going to do that because it has to interact with an appropriate partner. And of course, what it interacts with is going to decide whether or not it's going to be beneficial or harmful. So there could be context where it produces more harm than benefits. So this is why you have to also take into account the dispositions that are already there that you add the intervention to. You cannot just say, oh, we're only focusing on this event, which is I give you the intervention and then the effect, oh, they died, you know, or oop, they recovered. So you have to look at what is there so that you know whether this is an appropriate intervention for producing the effect that you want or not. So then it means that actually most of the dispositions that you need to consider is not in the pill, but in the context that you're adding the pill to. So it means that when you sit there with the patient is going to represent most of the causally relevant evidence that you could need. So it doesn't just, you know, instead of just having seen many, many times how many patients this would cure in the tested sample. So, and this idea of context sensitivity also means that you need to see which context is appropriate and which one is not appropriate. So you should never expect that two different contexts with the same intervention is actually the same treatment or even the same causal process. So I think I also had a slide for this. Let's see. This. So here, if you think of the intervention as the gray arrow, the light gray arrow, which is the same in the two different contexts, you see here that because of the different vectors and different dispositions involved and which direction they point and how much, it's going to change under the assumption of additive composition here. It's going to give you different outcomes. So in the first case, yes, you got the effect that you wanted, recovery, and in the other you didn't. And of course, you could here have a situation where the resultant vector is exactly the opposite, where it, for instance, would be a harmful effect. So this shows that two contexts with one vector being the same, namely the intervention, would not be the same kind of treatment. So that's one lesson to learn from here. So I think with the clinical guidelines today, it is the assumption that you can have a package solution or a standard or average or normal or best practice that should be given to everyone, at least everyone in a certain population. So this trend, I would say this is a very Humean idea of the same cause, same effect. So that if you have the same diagnosis, then you get the same treatment package, and then you should benefit almost in the same way. And here the default expectation is that people will benefit from the same things. So for instance, in Norway, we have started with package, package, I don't know if you call them package solutions, I call them package solutions, where, for instance, if you have a diagnosis of anorexia, it might tell you that you should have 14 hours of therapy and what each lesson should be about and which methodology should be used. And then, of course, if you need more, or if you need less, that would be a bit of a surprise. From a dispositionalist perspective, you would start from assuming that people need very different things. So even if you have anorexia, you should expect that two people have different dispositions and that their context is different, and also with different therapists that you would need to do different things. So if it turns out that people need the same, that would be the surprise. I mean, it is possible, but you wouldn't have a kind of theoretical motivation for expecting this. So on dispositionalism also, you would explain why it's possible or even expected that people should respond differently to external stressors and also to medical treatment. So for instance, if someone has a conflict at work and they end up being burnout, other people can say, oh my God, you're so weak. I have conflicts at work all the time and I don't go and lie in bed for 3 years, you know. But then you have completely missed out on what was there already when the work conflict kicked in, because that could have been a person that was in a very vulnerable state, you know, maybe also overworked, you know, so they were very close to the threshold of burnout, while you might be in a more robust state before a conflict, and then you can tackle it, you know. So to see how far are you in the vector diagram from the threshold effect is going to tell you something about your robustness to external stressors, you know. It's also going to tell you something if you're very far away from recovery, that you need to add a lot to bring you to the positive effect. Or if you're very close, you might need to do very little and people recover. And this is also why these packaged solutions, they wouldn't take into consideration those ideas. But of course, there is this idea of equality, you know, so it's justice and equality. But from this positionalist perspective, what is the best thing for you to get should depend on who you are and what your situation is and how you're going to interact with the treatment or the intervention. So it's not fair to give peanuts to everyone just because it's a great source of protein if some of you have allergies, you know. You could say, no, this is extremely fair and we want to have complete equality, but from a dispositionalist perspective, that's not how it works. And also medical uniqueness. On the dispositionalist perspective, this is actually an interesting case, because when you have someone who is unique and they get a unique response, for instance, from an intervention or a treatment, then you have a chance to look at very rare dispositions that interact in an unexpected way. So that if you see that, okay, so this treatment here that would normally be very successful, this person actually got much worse from it, and they interacted in a very unexpected way. So for instance, some side effects that are like, some people get curly hairs from a medication. I mean, it's not very harmful, but it's very surprising, and it can teach you something about what this drug actually does and which kind of manifestation partners produce certain effects. So in this dispositionalist theory, to have a marginal and outlier cases is a source of new insights. So by studying in detail these marginal cases, you might learn something more, you know. So it's a bit like if you think the dropping of the pen, you know, you drop it and it falls, and you can see that many times, but you're never going to arrive at the theory of gravitational attraction. You know, it's not like the theory is just because you count how often, it's never going to give you that. But if under some very rare conditions the pen doesn't fall, then you can learn something about causal mechanisms if you take that seriously. And I think a lot of these clinical studies where we see that many people don't get the expected outcome, and therefore they are not really taken into consideration. I mean, this is a lost opportunity because you could instead say these are really interesting cases for learning more about what this intervention can do in very particular contexts. And in many other fields, like in biology, for instance, this is something that is already there in the lab process. So you have very clear protocols, or where you write very clear notes, so that you can see if something unexpected happens, that you can go back and know exactly what was particular in that case, so you can develop your theory. But again, if you think that theory is speculation, like Hume did, then the theory development is just going to give you even more speculation. So it's not going to give you some hard evidence. So from this dispositionalist perspective, we shouldn't expect to have these average patients or average responses, or that everyone is diseased in the same way, or that they benefit in the same way from an intervention, that there is this best treatment that works for everyone. But instead, we should want to know whether a treatment is going to be causally efficient or beneficial or harmful for a patient by looking into who is it that we have in front of us. So instead of looking at every other patient and seeing, hang on, I'm first going to look at evidence from everyone else, and then I'm going to come back to you, you should spend more time finding out who you have here. And that would, of course, be a unique case with the biology, biography, external stressors, lifestyle, life situation, and all of those things that can influence, well, the process of recovery or illness. So that's why we say that one size does not fit all, and statistics don't get me, and that the uniqueness is the default of any causal process.